This notation says f composed of g, so it means you're taking the function f and you're putting the value of g into that function. And so up here it says when x equals -10, the function f is 11, function of g is 4. So we can figure this out by figuring out what g is. It's 4 in this column. And then we're plugging that into the function f of x. So we've got x equals 4 going into the function f of x. So we don't want to use this column when x equals 4, right? We're taking g, we're plugging it into f. So we need to use this column because we're plugging 4 into f, is what that's saying. So when x is 4, f is 4. I know the notation's really confusing there. So this one's in reverse. It's always, you've got to pay attention from left to right. This is saying you're plugging f into g. So when x is 4, this column is telling us that f of x is 4. Okay? So we're plugging 4 into the function g. So that's still coincidentally the same column. So g would be 11 when x is 4. Okay. So for this next one, this is saying you're taking whatever g is and you're plugging it into f. So when x is 7, g is -10. So that means I'm plugging -10 into f. So when x is -10, we get f is 11 here. And then last one of these composition ones, this says we're plugging whatever f is equal to into g. So when we're in this column, f is going to be -10. So that means we're plugging -10 into the function g. So we got to figure out what the value of g is when we're plugging in -10 into it. That's 4. Okay, confusing stuff. Okay, so this, let's see. This is asking what f is when this is 7. How are we going to figure that out? Okay, I got to pause it for a second because I haven't thought of this yet. Okay, these last two are pretty tough. I've taught calculus for a while and I haven't seen this exact version of this type of question. I've seen this before, this table, but not quite like this. Because look, this blank is saying, what is the value of f when x is 7? Right? And so in order to get that, the only way we could possibly get that is from this composite information. So here, this notation is saying f when you put g into it. So we can make these two sides match if we could have a g of x that equals 7. But if you look in the g of x column, there's no 7 available to us, so we're stuck. We can't figure this out from the information we're given. But I think if we start with this blank, maybe we could do it. This blank is g when you plug 11 into it. That's what we need to solve for this blank right here. So the only way we could possibly get that is by using this column, because this would result in g for the outer function. We need g of f of x to equal blank, so we want to have 11 in here. So look where f of x equals 11, that's right here. So that only happens when x equals -10. So g of f of -10, that would equal g of, if you plug in -10 for x, you get out 11 for f. And I think we know that one. If you plug in -10, then this results in 7. Okay, so we just figured out that g of 11 is 7. And I think now that we know that, we can get this part, because we needed 7 in here, right? G of x equals 7 when x is 11. Let me just double check because I'm getting myself confused here. We need this to match this. So that happens when x equals 11. And that makes this be 7, and then f of 7 would be the blank that we want. So we want to find out in this composite column when we have f composed of g when x is 11. And that's right here, and that would also be 7. Maybe it's trying to get us to go by patterns or something. There's 3 11s, there's 4 -10s. No, there's 4 11s, there's 4 -10s, there's 4 4s. So there should be 4 7s. I guess that's the other way of doing that, but that's not really calculus. 1 2 3 Yeah. Okay, but that's the algebraic way of doing that. Tough logic there.